Assalamualaikum and greetings everyone. Today's topic is on applications of triple integrals. So apart from finding volume of a solid, we can also use triple integrals to find mass, moments and center of gravity of a solid. Okay, now let's look at the first paragraph here. If a solid has a mass m and volume v and the mass is uniformly distributed throughout the solid, we say that the solid is homogeneous. So that's the first term. The mass density delta is defined as the delta here is the density is equal to mass divided by volume. Or you can rearrange the equation, then we can say that mass is equal to density times volume. So if the density is not the same throughout the solid, then we say that the solid is a non-homogeneous solid. Okay, the first formula for you today is mass of a solid. So we know that mass is equal to density times volume. But we know that to find the volume of a solid is equal to triple integral dV of a solid G. So for here we have the first formula, mass is equal to density of the solid integrate over solid G. So it's really density times the volume. So density integrate over solid G will give you mass of a solid. We'll come back to this example later, but I'm going to show you more formula involving applications of triple integral. So that's the first one, mass of a solid. Excuse me. We can also find center of gravity of a solid. So center of gravity is a point. So let's say the point is at x bar, y bar, and z bar. So the formula for x bar is triple integral x times the density. So you have x times density integrate over solid G divided by mass. So the denominator here is mass of a solid. Remember from the first formula, mass of a solid is density integrate over solid G. So that is for x bar. For y bar is equal to y times density integrate over solid G divided by mass. And for z bar is z times density integrate over solid G divided by mass over solid G. So that is center of gravity. But if the if the density of the solid is constant, then we can simplify the formula for x bar, y bar to this. Okay, so we have x bar is x integrate over solid G divided by volume. So the denominator now is reduced to volume. For y bar is y integrate over solid G divided by volume. And for z bar is z integrate over solid G divided by volume of solid G. So this is called centroid. So centroid is really center of gravity of a solid where the density is constant. Okay, so this formula can be simplified to this formula. Alright. Okay, next is moment of inertia. So moment of inertia, or also called second moment. We have three more formulas. One is for a moment of inertia of solid G with respect to the z-axis. So that is Iz. So this is the formula for moment of inertia with respect to the z-axis. So we have x squared plus y squared times density. This is the function integrate over solid G. And this is the moment of inertia of solid G with respect to the x-axis. And this is moment of inertia of a solid G with respect to the y-axis. So in this section, we just look at the formula for mass, moment of inertia, and also center of gravity and the centroid of a solid G. So how to evaluate the triple integrals? As you can see, they involve triple integrals. So how to evaluate the triple integrals depending on your solid G. So whether you want to use Cartesian coordinates, cylindrical coordinates, or spherical coordinates. So it all depends on the solid G. Okay, for the example, I'm going to save that to the next video. Thank you.